Hello, guys. Based on African motives are still on engineering science and four are working on revisions. In this platform, we shall be focusing on kinematics from the question paper of November 2020. This question paper is actually very, very much similar to the question paper of November 2022. So that is why I'm having this, so that we can see that some of the questions, they are actually taken from previous exam papers that have been attended. So it can be an advantage for you to revise more question papers. Like if you check 2020, 2022, they are actually similar. Okay, let's see what we have on question number 1.1. Without wasting much of our time, we are given that two cars leave a fork in a road simultaneously. Then we are given car X travels at 60 kilometers per hour. Okay, so that's car X, sorry, 60 kilometers to the west, all right? And car Y is traveling at 100 kilometers per hour in the direction of north, 45 degrees to the east. So what I want you to get note is, if you check the November 2022 question paper, you were given a certain direction written as, like, let's say 100 kilometers in direction, then they say northeast. All right, they can write it like this. This presentation is one and the same thing with the north 45 degrees to the east. Northeast, that is in between the north and the east. Remember, that's our north here, our east, in between. So it is going to divide into two, that is 45, 45. So a presentation like this, or a presentation given as northeast, is one and the same thing. Just like north 45 degrees, all right, north 45 degrees to the west, and it might be given direct as northwest. If they give you this as northwest, then it means is the same as north 45 degrees to the west. All right, so here I just wanted you to see that it's just one and the same thing. So that's why I'm having these question papers, guys, so that you see, okay, it's just one and same question. They are just repeating. All right, so let's take this into consideration and see what happened. Let's just have this in a form of a diagram. So that is our question 1.1. So we are given that these two cars, they're actually from a certain point. So let's say they are from this point here, where we are given our north, our south, our west, and our east in this case. All right, so let's take the first consideration, what happened with the first car. So the first car, it is X 60 kilometers to the west. So that is 60 kilometers direct to the west, meaning to say we are maintaining this in between the 90 degrees. We are going to travel straight into the west line like this, straight into the west line. All right, so that is our first car, which is X, which is at 60 kilometers per hour. So that's 60 kilometers per hour. All right, the other car that you are given is car Y, which is at 100 kilometers per hour. That is northeast, the same that I was saying, north 45 degrees, same as northeast. So this is in between the north and the east, that is separated by 45 degrees. This is your north, your east, in between like this. So this angle is going to be 45 degrees. So that's our car Y in this case, traveling at 100 kilometers per hour in this case. All right. So with this diagram, you can actually attempt any part that you're given. So in this case, we need the relative velocity of car Y with respect to car X in magnitude and direction. All right, so let's check what we got between these two cars that we have. Okay, if you were to consider this, we can just join this part that is from X to Y, just complete our diagram. So that means here we can actually apply our mathematical skills in order for us to solve this. That is finding the resultant from X to Y. This is going to be your resultant. Remember, this angle here is 90 degrees at this point. So that means the 90 degrees here and this 45 degrees combined together gives us an angle of 135 degrees. This angle is the one that you are going to consider. So you're adding from this point to this point, which is the 45, and from this point to this point, which is the 90. So everything is going to give us 135 degrees. So in actual sense, you're actually presenting a triangle of this nature. In this case, we are simply having a triangle like this. We are simply back to your solving triangles, where you are given a triangle with two sides 60, and this is 100, and you are given this as 135 degrees. You want to calculate this side, which is your resultant in this case, and you want to calculate this angle, which you might call as alpha. That is the angle in between here, just alpha. So which concept are you going to use? Which concept are you going to apply? That is the application of the cosine rule. We have got two sides included angle, so you can apply your cosine rule. You're back to your mathematical skills. So that's all about these typical questions. So let's try and apply our mathematical skills here. From our cosine rule, we know that a squared is equivalent to b squared plus c squared minus 2bc, the cos of a. So which means we can obtain this A representing our resultant in this case, which is R. So that means our R, if we are to introduce the square root, we can remain with A in this case. Our A is representing R. So it means our R is going to be equal to the square root of B squared plus C squared minus 2BC, the cosine of A. I always say this so that you understand, guys, that A and B are simply, the B and the C, these two sides are simply the sides creating the angle that you are given. So you can name this A, you can name this B, the sides that are creating the angle. These two sides, that's your A and your B. So one is going to be A, one is going to be B and C. So let's just say B and C here according to our formula. So this will be our B and our C. All right, so meaning to say we can just put plug in our values here, the 60 and the 100, so that this is going to be R is equal to the square root of 60 squared plus the C here, which is the 100. So this is going to be 100 squared minus 2BC, again, the B and the C, your sides. So this is going to be 2 by 60 by 100. And take note, everything must be under the square root. So the square root is supposed to cover up everything, including the cosine of the angle of 135 degrees like this. All right, so this whole part is going to give us the resultant, which is the velocity between y and x of 148. So this is going to be 148,61117. So if you round off to 3 decimal place, that is going to be 611. All right, it was 61117. So it's going to be 1 in this case. The units in kilometers per hour, So your answer is going to be also kilometers per hour in this case. So that is our velocity that you're going to have. And from this information that we have, still we have to calculate the angle alpha, as we saw here. This angle between, you can refer to this as theta or as alpha. So that means we can apply our sine rule in this case, because if this we are to substitute our resultant here, we have got 180, that's 148. So this is 148,611. So kilometers per hour. So we are now having a condition of an angle to the side. We want to calculate an angle and we are given the corresponding side. So this we can simply apply our sine rule. So to calculate alpha, which is our angle in this, we are going to apply the sine rule, knowing that the sine of A over A is equivalent to the sine of B over B in this case. So that means the sine of the angle over the corresponding side. So our angle is alpha. So that is the sine of alpha over the corresponding side. It corresponds here with 100 is equal to the sine of an angle that is corresponding with the side. So we're going to use this with the resultant, because for this 60, we do not have this corresponding angle. So there's nothing that we can do. So that's why we have to consider the whole of 135 with the resultant. All right, so this is going to be sine of 135, everything over the resultant of 148,611. So by this, we can calculate our angle alpha, that is removing the 100, that is that is dividing here. We can multiply both sides by 100 to remove the 100 that is dividing here, same as 100 over 1. If you multiply by 100 over 1, this simply cancels this. You remain with a sign of alpha in this case. So the sign of alpha is going to be equal to 100 times the sine of 135, which is 100 sine of 135 degrees, everything over 1 times 148,611, which is going to remain like that. All right, so this gives us the angle alpha. If we are to simplify the arc cos, the arc sine of this gives us the exact angle for alpha now. So here our alpha is going to be arc sine of this. So you just indicate on your calculator that's shift sine this arc. So you just arc sine, you write everything as it is, plug in your values as they are on your calculator, 135 degrees, everything over 148,611. This is going to give us the angle alpha in this case. All right, so the angle alpha can be given, you can even write this as angle theta. It's just one and the same thing. It's a presentation. You can write this as beta, any presentation that you can use to find or to represent an angle. So this is going to give us 28,41213, which is going to be 412 to 3 decimal places as per given instruction from your question paper, depending with what you're given for that particular paper. So in this case, this gives us the resultant that we are given. So the resultant, according to what we are given, we have got our resultant and the direction in this case. So that means we can present our final answer as 148,611 kilometers per hour in this case at then the 28,412. If we are to check, this is between from this direction, this is going to be taken. If you check now, this here is going to be our west, and this will be our east, north, south. So this is between east going to the north. So it's going to be east to the north. All right. So this is going to be east. We can present this as east, the angle to the north. All right. So that is going to be east 28 degrees. So you've got 28,412 degrees to the north. All right, so this can be your final presentation in this case. So these are the typical questions that you might be given. All you need is to play around with your diagram, the formulas from your mathematical presentation there. We can apply back that part. All right, so let's check the other part of the question 1.2, where we are given that a boy throws a cricket ball at an angle of 15 degrees to the horizontal with an initial velocity of 50 meters per second. The path of the ball is that of a projectile. So we are given that the way the ball is going to be, the way the ball was thrown is the same as a projectile. So we are going to present how our projectile, so we've got an angle of the projectile and also the initial velocity of 50 meters per second. All right, so that's 1.2. I'm just going to have my diagram here. All right, so on 1.2, we have got the initial velocity of 50 meters per second, and we are given the angle between, which is of 15 degrees in this case. And we are given this follows the same path of a projectile. And we know that for a projectile having our velocity and time, we are going to have a presentation of this nature. All right. So this is what you're going to have like this. All right. So here we have our angle, which is 15 degrees. All right. We have got 15 degrees. Our initial velocity here being of 50 meters per second. All right. So this is just a graphical presentation that you can have with your velocity versus your time in seconds. So what are we given on the first part of the question? This is to calculate the following: the time to reach the maximum height. Take note here, we need the time to reach the maximum height. All right, whenever we are representing for the maximum height, all right, so this is what you have. Let me just present here. All you need are formulas. You need to know what to use whenever you're dealing with these conditions. All right, so let me just write this 1.21. So for maximum height, this is what you need to know. Last time I presented formulas where we calculate the maximum height, but in this case, we're not calculating the maximum. We need conditions which occurs at the maximum height. So at the maximum height, the initial velocity is the velocity that we are going to obtain from the vertical, which is UI. That is going to be our initial velocity, all right? Our initial velocity is going to be equivalent to this initial velocity from u. We are going to find this as uy, okay, from the vertical, which is given as u sine of theta. All right. If we are to determine this, this is our initial velocity, all right? So our initial velocity is going to be u sine theta, which is 50 sine of theta, that is 15 degrees. So if you are to simplify this, you are going to obtain 12,941 in meters per second. All right, so this is your initial velocity. Your final velocity for a maximum height is going to be taken from 0 because we do not have any movement at there. So our V is going to be at rest, which is at our final velocity, which is 0 meters per second. Taking our gravitational acceleration to be a negative for this condition of 9.8 meters per square second, that means we can calculate the time frame between these. So with this information, what you're going to do is to apply that concept of linear motion where you are given the initial velocity. We've got the initial velocity, we've got the final velocity, we've got the acceleration. So the g is simply representing in place of a, that is our acceleration for this, taken as a negative. So which formula are we going to use in this case to calculate the time? If you are to consider, we have got formulas such as V is equal to U 80, V is equal to U plus 80, like this, where we are given the final velocity, the initial velocity, the acceleration, and the time. Meaning to say we can play around with this formula to calculate the time, because here we have everything from this. We have got our A representing the acceleration, which is G, our U, which is UY in this case. So this is going to be UY like this, all right? So we can substitute our values so that we can obtain the time when this is a maximum height. All right, so let me just put it this way so that I can just utilize this side here. We do not need this diagram. We just need this information here. So we can play around with this information that I'm having. So from this, we said from V is equal to UI plus 80. Our V is the final velocity of 0. So 0 is equal to UY according to the vertical, which is 12,941 is that is a plus the acceleration, which we said is going to be taken as a negative 9.8. So this is negative 9.8 times t. So this is what you're going to have like this. That's our AT. So we can calculate this, transpose the negative to this side so that it can be a positive. That will be positive 9.8 t is equal to 12,941. So you can calculate t if we divide by 9.8 both sides, by 9.8 both sides. So you can have the value of t representing the time that was taken, which is of 1, so this is going to give us 1,321 seconds. All right, so the time is going to be in seconds in this case. Remember, your velocity is in the meters per second, so the time, that's in seconds in this case. All right, so that's how you can actually calculate this part. All right, so you just have to play around these typical questions, guys. Just have to play around. All right, so let me check back. Okay, this is where I'm having my question now. Let me check back so that all right, so from the same information that we are given, now we need to calculate the maximum height reached by the ball. Okay, so previously We were working with the time for that particular maximum height. Now we need to calculate the maximum height. Okay, so like I said, this question is the only part that we didn't have from the November 2022. We do not have this part, but this, we were having this part on that paper. So it's actually repetition that we are having on these papers. Okay, so, and I explained the formula that you can actually use to calculate the maximum height in this case. So I'm gonna have this as 1.22. Remember, guys, what I told you, the maximum height can be given as h max, which is equivalent to u squared over 2g times sine squared theta, like this. So this, you do not need anything. All you need are the initial values that we were given before for this that we are given, the initial values, our u and our theta. So our u being 50 meters per second. So this is what you're going to have here. So that means our h max is going to be u, which is a 50 squared over 2 times g, which is 9,8 times the sine squared theta, means the sine of the angle that you're given of 15 degrees. Then you square everything like this. That's sine squared theta. You write sine 15 as it is, then you square the whole bracket. So on your calculator, this 15 is going to be in a bracket like this. That is how your calculator is going to give it, like, but you square the sign. So you open the bracket before you write the sign. All right. So that's how you can present it on your calculator. All right. So from this, we can have the maximum height, or which is going to be 8,544 in meters. All right. So the units here are in meters. So it's going to be in meters in this case. Or you can actually have the same height if you are to use the formula of S is equivalent to UY times T plus half G T squared. So you can actually apply this formula. Still, you're going to obtain the same thing, or the same answer in this case. All right, so that was our 1.22, calculating the maximum height reached by the ball. Then if we check on 1.23, now it is to calculate the horizontal displacement of the ball, the horizontal displacement, which can be given by S X in this case. So for the horizontal displacement, I also gave you this formula. I think we still remember this formula, that SH can be given as U squared, the sine of 2 theta, everything over G, like this. So this can give us direct what we need, which is also referred to as the range. So if the question is asking you for the range, it is same as the horizontal displacement, which you can just sub. The U is the initial one from the given information that you're given, which is the same as the 50. So it is going to be 50 squared times the sine of 2 theta. That is the angle that you're given. So it's 2 times our angle. This time it was 15. So we are going to multiply 2 times 15 like this, everything over G. So take note, when you are using this formula, our G is a positive. You use G as a negative when you are using the formulas for linear motion, these ones. That's where you use your G being a negative. But on this one, you use your G as a positive, as it is. So that is 9,8. All right, so this gives us our SH, which is the horizontal displacement, or the range in this case. So that is going to give us 127,551 in meters. All right, so that's what we had on 1.23, not 1.22, 1.23. So this is actually 1.23. Remember, we had 1.22 here. So this is 1.23 on the horizontal displacement, or the range in this case. All right, so these are the typical questions that you might be given, and you have to be very, very careful. Let's check the other part of the question that you're given, which is on question 1.3. So on question 1.3, now we are given that from this information, a canoeist is rowing on the Val Dam, so at a velocity of 4 meters per second northeast. So this is a canoeist that is having a certain velocity of 4 meters per second in the northerly direction. So this is going like this to the north with 4 meters per second. Then a wind of 3 meters per second suddenly starts blowing. So there's a wind that is traveling with 3 meters per second in the direction of southeast. So this is like this. That's our south, our east. So the wind is traveling in the southeasterly direction like this. Okay, that is at 3 meters per second. Calculate the resultant of the canoe in magnitude and direction, 5 marks. So you need the direction, the magnitude, and the direction in this case. Okay, so what's going to happen between these two? If you are to check, we are going to have, this is the canoe square that is going up, and this is the direction of the wind in the southeast. So at the end, we are going to have our canoes that is going up like this. All right. Then the wind that is between the north, the south, and the east. So this is going to be like this in between. Take note, this is at 45 degrees. This is at 45 degrees. So if we are to join this is going to be joined at 45 degrees. So we're going to join this at 45 degrees like this. Okay, so that means in between, we are actually having a 45 degree here, but what matters is the angle that we are going to have inside our triangle like this 45. So this is 4 meters per second that is going up to the north. So that's where we have our 4 meters per second, and this is the wind that is at 3 meters per second like this. So the resultant is therefore going to be from this point up to this point. That's our resultant, and what we need is to know the direction, that is the angle of theta. So you can refer to this as theta or as alpha, depending with which part do you want to use. So you can write this as theta. You can use alpha, whatever part that you're comfortable with. So if you are to check, this is actually a repetition of what we had on the previous question on this part of 1.1. But only that the diagrams are a little bit different, but all that you're going to have on this the calculations are going to be simply one and the same. In this case, to have the resultant, as you can see, it's a non-right angle triangle having two sides which are creating the angle of 45 degrees in between. So that means we are going to use the formula that we applied last time, where I said R is equal to the square root of B squared plus C squared minus 2bc, the cosine of A. I think we still remember that formula that we manipulated to make R the subject. So that means we can actually substitute our values. The B and the C are the sides that are creating our angle, which is the 4 and the 3. So this is going to be 4 squared plus 3 squared minus 2 times the 4 again times the 3, 4 and 3 times the cosine of the angle between the given sides, which is the angle of 45 that is inside the triangle here. So this is going to be the cosine of 45. So this gives us the resultant. From this information, we are going to obtain our resultant, which is in this case going to be 2,8336, something like that. So this is going to be 3, 4. Okay, the units, meters per second, meters per second. So this is going to be in meters per second. Then to calculate the angle, which is our theta, since we have our resultant, we can substitute our value here of 2,834. So that means we are back again to the sine rule, because we have got, and we need to calculate an angle given the opposite side, and we have got an angle with an opposite corresponding side. So which means we can apply back our sine rule, which says that the sine of A over A is equal to the sine of B over B. Remember how we apply our sine rule, guys? We are going to substitute our values. That is the sine of the angle that we are calculating, which is theta, over the corresponding side. It corresponds with the 3, which is equal to the sine of the 45. This is the angle that we are given. So it's 45 over its corresponding side. 45 corresponds with the resultant of 2,834. So this is what you're going to have. So in order for you to calculate the theta, you can remove these 3, multiply by 3 over 1 both sides, by 3 over 1 both sides. So this simply cancels. We remain with the sine of theta, which is equal to 3 times the sine of 45 over 2,834. So this whole part can give us the angle of theta. So just like the previous part, remember, in order for you to obtain the theta, is going to be arc sine of this. So theta is going to be arc sine, which is a shift sine from your calculator. So shift sine this, that is the arc sine. So it is going to be arc sine of this 3 sine 45 degrees, everything over 2,834. So this is going to give us the exact angle of theta, which is in degrees in this case. Make sure that your calculator is in degrees. So our theta or alpha, depending with how you've written that angle, is going to give us 48,463 degrees. All right, so this is the angle that is between, which is the angle between. So this is the one that you're going to use on our final answer with our resultant. So we can actually present our final answer to say our resultant is going to be, we are going to have our R being equal to 2,834 meters per second at, we are now representing our final answer. So this here is actually, remember, this is between this pole here. This is the north. And if you have to check here, we are going to the east. So it's north to the east. We are from the north going to the east direction. So our answer is going to be north between an angle of 48,463 degrees to the east, because it is between the north and the east pole. So in between the north going to the east, that's where we have our angle, which is the direction. That is what is important in this case. All right, so this was the diagram that you're going to have at the end, and the required calculations that you can apply from this information. So it is very, very important for you to note the information that you're given, the steps that you're supposed to take. The diagram that you are going to use is the one that gives us the formula. Sometimes you're given a right angle triangle. There's no need for you to apply the sine rule or the cosine rule. You can apply the trigonometrical ratios and the Pythagoras theorem, depending with the information that you're given. All right, so that was the question, guys, on kinematics from this question paper. It's very, very important that we revise more question papers for revisions before exam. Like I said, this was just because of the November 2022 paper. So that's why I'm bringing this, the whole of the 2020 paper also, so that you'll see that it was actually almost one and the same. Okay, for now, guys, that's it from Maison African Motives. Till we meet again.